As part of TigerGraph challenge, we built a multimodal cancer graph, as in Sara, El-Ateif, me, and Sofia Bohim, an all-women team, part of the AI Wonder Girls. We got inspired from the Drug Repurposing Knowledge that performed detection from diseases like to compounds. So for example, if you have COVID-19, what are the drugs that you need to take or that you can take? We used the multimodal cancer network from the SNAP library. We prepared the data, fed and designed the schema, loaded the data inside TigerGraph, and built a model using Torch drug library to perform disease link prediction. As for the data we had 5 modalities, which are called chemical, protein, gene, function, and disease. And as you can see, they have different relationships between them. But what we were interested in was to detect the relationship between diseases and predict new links, new diseases. That's why we took the data and we transformed it into triplets format. And we split it into train, validation, and test. We defined it as a graph inside Torch drug, and then we fed it to the rotation E method that helped us guess the embedding of our data, like a compression of the data, and fed it to the knowledge graph completion model that will perform the prediction of new diseases through, of course, a certain disease. So our aim was to make it easier for clinicians to understand the interaction between different cancers and discover new variations so that it can help them come up with drugs to cure them. So we used for that, so we loaded data into TigerGraph, which could help them read the data and understand the different interactions easily by going through the different relationships into that database. So in the future, we aim to get more data to include compound side effects and cover all cancers, make the querying system intuitive by using text instead of GSQL. As in, for example, if I'm interested to know breast cancer, the relationships between genes, proteins, and the disease, I might just write that instead of having to use a querying system, and then infer more meaningful links like disease, gene, and gene.